In today's video, we're going to find out if it's possible to melt salt and cast it into different shapes like you can with metal. And if it is possible, then what kind of results can we get? Salt, or sodium chloride, has a surprisingly high melting point. It's almost 1500 degrees Fahrenheit, which is 300 degrees hotter than aluminum's melting point. For some reason, it's crazy to me that you could just stick pieces of aluminum into molten salt and the aluminum would just instantly melt. But anyways, I shouldn't have any problem melting it because I use this furnace routinely to melt copper, which has an even higher melting point. But the real question here is, what happens when you cast it into a mold? The first thing I need to do is figure out what I'm actually going to make. This is a box full of patterns that I've used in the past to make things out of metal. There's tons of things in here, but I need something fairly simple. I think one of these giant megalodon teeth would be a good place to start. I've cast a bunch of these in bronze before, and they always turn out really nice, so maybe they'll look pretty cool made out of salt. This dagger was one of my first bronze castings. I'll try to cast one of these too. And finally, this is a bust that I made a few years ago out of brass. It's not really ideal for sand casting, but I'll try it anyways. I'll be making sand molds to create these castings, but before I do, I want to try something. This is pink Himalayan salt. It's pink because it contains small amounts of trace minerals. It's also fairly transparent, and that comes from the crystals forming very slowly, which is the opposite of what I expect to happen when I cast it into molds. I want to see if I can recreate this transparency using my kiln. I made some really simple open molds out of ceramic, and I'm going to place these inside my kiln and fill them with salt. Then I'll raise the temperature to above the melting point of the salt, which should cause it to melt and flow into the molds. After that, I'll let everything cool down very slowly, and we'll see if that results in clean, clear-looking castings. This is actually very similar to how people cast glass without ending up with a bunch of cracks. I'll let that heat up, and we'll check back on it in a bit. Alright, back to the sand castings. I'll make these molds pretty much the same way I would make them if I were casting metal. I'm also using the same oil-bonded sand that I use for metal. And I'm going to be making 4 molds, so I don't want to bore you with that. I'm just going to show you how I make one. Alright, the molds are ready to go. Let's fill a crucible with some salt. This salt is probably going to destroy my crucible, and these things are pretty expensive at about $100 a piece, so I hope this is worth it. Let's check on the kiln. It's been a few hours since I put these in here, and it's hard to tell on video, but they are completely molten. So I'll turn it off now and let them slowly cool down. Alright, it's time to melt some salt. I'm not sure if this molten salt is going to produce toxic fumes, so I'll be wearing a respirator the whole time. I made a last-minute decision to make an open mold with these skulls, so we'll see how well that works too. Unlike metal, this stuff is incredibly watery, so it was really hard to pour neatly. I really love how you can see the smoke coming out of the vent holes like little smokestacks. After pouring the first 2 molds, I refilled the crucible, and I noticed that the salt that got submerged started to bubble. I'm not really sure why this was happening, so if you know, let us know in the comments. Unfortunately, as I was bringing these molds back into the shop, the bottom fell out of this one and broke up the skull castings. It's kind of a shame because they actually look really nice, but it makes me excited to see what the rest look like. I'll start with these skulls. This was just an open mold, so let's see what it looks like. Oh yeah, that's actually not too bad. I think that looks really good. I'll have to remove all this sand, but I think it actually looks pretty good. That's really promising. And it's in one piece, so that's cool. Yeah, that one looks good too. All right, that's really promising. Wow, that looks really good actually. It's kind of cracked, but wow, it looks like it's just made of bronze. It has this metallic sheen to it that just makes it look like metal. Here we go. Yeah, look at that. That looks amazing. This looks as good as a metal casting. And if you didn't know, this is actually the back. This is the front of the tooth. This is the part that you would see. And then this is facing in towards the mouth, but this is the part that we always display. Let's try this statue next. Yeah, that looks good. This looks shockingly good. Look at all the detail in this. This is salt. That's unbelievable. All right, let's flip it over, see if it's in one piece. Looks like it is. All right, that looks great. Man, that looks so good. Look at the detail on this. It's just unbelievable to me that this is salt. We have one more to open, and this is the dagger. If any of these castings is going to be cracked and in multiple pieces, I expect it to be this one. That's just because it's really long, and I think the cracks are going to be running this way, so I think we're going to find that it's going to be in multiple pieces, but only one way to find out. Let's open it up. Yeah. Looks like there's a pretty significant crack right here. Obviously it's separated here and here, but overall it's actually not bad. I think there's still something really cool about this broken up dagger. I think it looks really neat. All right, let's take a look at these now. They actually look pretty good, and compared to the sand castings, they're extremely clear. Look how well light passes through this one compared to the sand casting. I figured the sand castings wouldn't be quite as transparent, but I didn't expect that they would be nearly black. The problem is, it seems like the castings are stuck in the molds. And now that I think about it, the ceramic material I used may not have been the greatest choice for this because it's fairly porous, which means that the salt probably penetrated the shell and now they're hopelessly stuck. But it's easier said than done to find a material that would work for this. My plan here is to use that porosity to my advantage and allow the ceramic shell to absorb water from the outside and dissolve a thin layer of salt, which hopefully will allow the casting to be released. Unfortunately, this didn't work at all. I couldn't get the castings out, but I think it was worthwhile because it demonstrates the importance of allowing the salt to cool slowly and form nice large crystals. I'm not really sure what I'm going to do with this one. It looks really nice just like this. Maybe I'll just put it on the counter in the kitchen and it can be a communal salt lick for my family. Well, I think this was a really interesting experiment, and I'd like to try it again using some different things like maybe glass or even borax. And please let me know if you have any suggestions. Well, I hope you enjoyed the video, and if you did, please give it a thumbs up. Thanks for watching, and I'll see you in the next one.